The oxyacetylene torch is commonly used for cutting metals. Oxyacetylene cutting of mild steel is fast and easy. An oxyacetylene torch can be used to cut mild steel in thicknesses ranging from sheet metal to plates several inches thick. When properly performed, oxyacetylene cutting of plates can be as clean and accurate as if the plate had been sawed. In this program, you'll examine the different types of torches used for oxyacetylene cutting and see how they're assembled. And you'll perform a series of practice cuts. Oxyacetylene cutting works by heating metal to its kindling temperature. Kindling temperature is the point at which a material will begin to burn. Mild steel begins to burn in pure oxygen at about 1500 degrees Fahrenheit. An indication the metal has reached cutting temperature is its dull red color. When this occurs, a lever on the torch is depressed, directing a stream of pure oxygen on the hot surface. Oxyfuel cutting may be referred to by a number of non-standard terms, such as burning, torching, or using a smoke wrench. An oxyfuel cut should be clean and straight, but there are many problems that can cause the cut to be unacceptable. By taking the time to clean the cutting surface and adjust the torch properly, a professional welder can make clean, consistent cuts.
It's super quick. You can normally leave your material laying in any position. You can burn up, you can burn down, sideways, and you do not have to manhandle your materials, so it's very efficient. And it's also efficient in terms of dollars. Gases and oxygen are cheap, and it gives you a very clean cut.
Let's look at oxyfuel cutting torches. The two most common types of torches are a combination torch and a dedicated cutting torch. With a combination torch, the torch head is removable from the handle so that the handle can also be used for welding or brazing. Combination torches are commonly used in small welding shops, schools, auto body shops and auto repair work, and a number of trades such as air conditioning, refrigeration, and plumbing. The dedicated cutting torches are designed for larger jobs in large welding and fabricating shops. A longer handle allows the operator to be further from the heat generated when making cuts through thicker material. Most cutting tips are manufactured from a copper alloy. Copper is used because it resists spatter and dissipates heat. There are two types of orifices found on the end of the cutting tip. A series of small orifices found on the outside of the tip are used to produce the preheat flame. The center orifice is used for the cutting stream of oxygen. Cutting tips can have as few as one preheat hole for cutting thin-gauged sheet metal to as many as 8 preheat holes. Most cutting tips have from 4 to 6 preheat holes. The larger the number of preheat holes, the hotter the flame, and the more quickly the metal will become hot enough to start the cut. However, too many preheat holes may overheat the part being cut. For most general-purpose cutting, tips should have from 4 to 6 preheat holes. The diameter of the center preheat holes determines the capacity of the tip. The larger diameter holes can handle higher cutting pressures, which are needed for cutting thicker metals.
If you don't have a good tip, you can have the right pressure, but tips also, that's one of the things that you have to watch out for, because there are different kind of tips for different thickness of material. So you also have to watch for that one.
Now let's look at oxyfuel setup procedures and torch assembly. Setting up the cylinders, regulators, and hoses for cutting is no different than the setup for welding, brazing, and soldering. Attach the cutting head to the torch handle. On most torches, the cutting head is hand-tightened to the handle. Check the manufacturer's recommendation because over-tightening can damage the torch. There is no standardized system for identifying the size of a cutting tip. You must refer to the manufacturer's chart to identify the appropriate tip. Remove the tip nut. Set the tip in the seat and replace the nut. Some torches use a soft gasket seal. This nut is hand tightened. Most torches have metal-to-metal seals, and the nut is wrench tightened. Check with the manufacturer's specifications for your torch to determine how this should be tightened. The combination torch handle has two valves. The oxygen valve on the torch handle is completely open. The oxygen flow to the flame is adjusted using the oxygen valve on the cutting head. Now let's open the acetylene valve and allow the hoses to be purged. When the acetylene hoses are purged, close the acetylene valve and depress the oxygen cutting lever. Then purge the oxygen lines. The torch is now ready to be lit. Slightly open the acetylene valve and hold the striker at an angle next to the tip. Once the flame is lit, turn up the acetylene flow until the flame stops smoking. Now, slowly open the oxygen valve on the cutting head. Increase the oxygen flow until a neutral flame has been obtained. Changes in the flame are caused by the pressure drop that occurs in the oxygen hose when the cutting stream is turned on. When this pressure drop occurs, the flame will become slightly carbonizing. While holding the cutting lever down, readjust the flame back to neutral. When the cutting lever is released, the flame will become slightly oxidizing. This can be helpful in starting a cut because the oxidizing flame is slightly hotter than a neutral flame. But when you are cutting, the preheat flames should be neutral. A neutral flame is important for a good, clean cut.
There's not a preset distance or what have you. Again, different thicknesses would cause you to regulate that heat setting. And again, that's experience, but I think the best way to adjust it is by eye. I mean, and you can, someone has to train you and teach you the proper way. You'll know when you're not doing it right, when you can't burn. And that's really it.
The first practice cut we're going to make will be a square cut made in a straight line using a 1/4 inch plate. Using a straight edge and soapstone, draw several parallel lines about every 1/2 inch across the plate. With the torch off, we're going to practice moving along the line. There are two ways to hold a torch for oxyfuel cutting. One method is to rest the torch tubes on your left glove and draw the torch toward you once the cut starts. The other way is to position the torch at a right angle to the cut and slide your hands along the plate as the cut progresses. Both methods work well, and it is an individual preference as to which method you prefer to use. Now, before you start cutting, make sure there are no flammable materials in or around the work area that the hot sparks from the cut might ignite. Also, be sure that the slag from the cut is not going to stream directly onto the concrete floor. Put on your cutting goggles and leather gloves, light and adjust the torch, brace yourself, and bring the flame down on the line at the edge of the plate. Hold the flame on the edge until the metal begins to glow. Depress the cutting lever and begin moving the torch flame along the line. Keep the tip of the preheat flames about 1/8 of an inch above the plate surface. Using a slight 5 or 10 degree angle in the direction of the cut will aid in the preheating. When you reach the opposite end of the plate, the cut piece will fall off. Turn off the torch and examine the cut. There should be little or no slag along the bottom of the cut. The drag lines across the cut should be straight or only slightly curved. Repeat this cut until you're able to make clean, straight, slag-free cuts. Next, we're going to make a straight cut on thicker metal. We'll be using a 1/2 inch thick mild steel plate. For this thicker material, we're going to look at the tip chart and select the proper cutting tip. Change the tip and set the pressure according to chart recommendations. Hold the torch at the edge of the plate and allow the preheat flame to bring the surface up to a dull red color. Note that on this thicker material, it's more important that you travel at an even rate. Any jerkiness in your movement on thicker metal leaves a more pronounced groove in the cut surface. If these grooves are too deep, they may have to be ground out before the plate can be used for welding. All freehand cut surfaces will have some degree of ripples. Bracing yourself will help reduce these significantly. When starting a cut on thicker material, hold the torch so that the tip is pointed square to the plate or pointed slightly away. This will minimize the amount of slag. Once the cut is started, rotate the torch so that you have a 5 to 10 degree angle in the direction of the cut. There are a number of problems that can occur during a cut. A common problem is excessive slag adhering to the bottom edge of the cut. There are several potential causes of this problem. These include too much preheat, a dirty cutting tip, too little cutting pressure, too much cutting pressure, and traveling too slowly. Another common problem is having the tip backfire. Tip backfiring can be caused if the tip is held too close to the work and overheats. The tip can also overheat if the flame is not adjusted correctly. Backfiring can occur if the tip seal is damaged or the tip is dirty. Beginning a cut in the center or making a hole in the plate is known as piercing the plate. Start by bringing the preheat flames down to the surface so that they slightly touch. This will speed up the heating and aid in initiating the cut. When the plate surface becomes red hot, slowly pull the cutting lever. Raise the torch tip up slightly as the cut begins. Move the tip slowly along in the direction of the cut as you increase the cutting stream by further depressing the cutting lever. When the cut has completely pierced the plate, lower the tip to the proper height and gradually spiral outward from the center until the hole is the desired size. Let's look at some ways to improve your Oxyfuel cuts. You can use a straight edge, such as this angle iron, to guide the torch when making straight cuts. Clamp the angle iron so that it is offset from the line a distance equal to 1/2 the diameter of the tip. This will allow the center cutting stream to follow along the line. You can minimize the amount of slag that forms on the cut by slightly angling the cut towards the scrap side. Most of the slag will then adhere to the scrap side of the cut. It's often assumed that a higher cutting pressure creates a cleaner cut. This is not true. Each cutting tip is designed for a specific flow rate based on oxygen pressure. As the flow is increased, turbulence will begin to form in the cutting stream. Turbulence usually results in a poor cut. In addition to decreasing the quality of the cut, higher cutting pressures result in sparks being thrown further away from the cutting area. Higher cutting pressure also results in greater oxygen consumption. Now let's review the key segments of the program. 1. Oxyacetylene cutting works by heating metal to its kindling temperature. Kindling temperature is the point at which a material will begin to burn. Mild steel begins to burn in pure oxygen at about 1500 degrees Fahrenheit. 2. There are two ways to hold a torch for Oxyfuel cutting. One method is to rest the torch tubes on your left glove and draw the torch toward you once the cut starts. The other way is to position the torch at a right angle to the cut and slide your hands along the plate as the cut progresses. 3. You can use a straight edge, such as this angle iron, to guide the torch when making straight cuts. Clamp the angle iron so that it is offset from the line a distance equal to 1/2 the diameter of the tip. This will allow the center cutting stream to follow along the line.